Hi, let us discuss the solution of this problem. In this problem, we are given two sorted arrays A and B of length L1 and L2, and we need to get the sums. Now, what is this sum? Suppose we have 1, 2, and 3 and 4. This is the Bth array, this is the Ath array. Okay, they're given in the test case. So what we need to do is we need to have possible combination and take out the sum in such a way that one element is from A and one element is from B. So if we take in this fashion, this would be 1 plus 3. So 1 plus 3. And if we take in this fashion, this would be 1 added to 4. So 1 added to 4. Then we would come to this one. And if we take in this fashion, that is 2 added to 3. So that is 2 added to 3, and then we have 2 added to 4. Okay, so we have 2 added to 4. So if we have the sum as 3 added to 1 is equals to 4, 5, 5 and 6. But we are told that we need to have the unique elements. So if we get all the repetitive elements, remove all the repetitive elements, that is 5 is the occurrence of 5 is 2 times. So if we remove the occurrence of everyone except 1, that is removing this, 4 is occurrence is 1, 5 occurrence is now 1, 6 occurrence is now 1. So if we remove them and add it in the sorted manner, that is 4, 5 and 6. Well, this is the first element, this is the second element, and this is the third element, and we need to report the third element. That is why the solution to this is 6 itself. Fair enough? So now, what are the things we need to do? We need to suppose this is A1, this is A2, this is A3, this is A4, and this is B1, this is B2, this is B3 and B4. So the most easiest solution that we can think of just by doing that in a pen and paper is we take this element and try to pair up with all the elements given in the B. Now, the second option is that we take up this element again and we try to pair up with all the elements given here. Fair enough? Now, we can take this element also and we need to do the same. Okay. So now what we can do is we can use a for loop to iterate over this element, and to iterate over all this element, we would again use a nested for loop. So for each element, we would iterate for L1 other elements. So for one element in A, the number of operation would be L2. Why? Because L2 is the length of the Bth array. Now, for suppose L1 elements, okay, for L1 elements, we need to do multiplying L1 on both sides, that is L1 into L2. Okay. After having a time complexity of L1 into L2, we would have all the elements. So now what you need to do is, suppose you are solving a question itself. So the first thing that you need to do is you took out the elements. Now before moving forward to removing the duplicacy and having them in the sorted order, first see to it that taking out the elements is within the time limit or not. Let's move to the time limit also. So what is the time limit that is permitted to us? So we have L1 and L2 as 500 itself. So if we have 500 multiplied by 500, that is the upper bound, we just take the upper bound, that is 25 multiplied by 10 to the power 4, that is nothing but 2.5 into 10 to the power 5. So we can say that 2.5 into 10 to the power 5 is less than 10 to the power 8 itself. So this is very much feasible and we would not have a time limit exceeded error. Okay, fair enough? So we now know that taking out the elements is within the time limit. Fair enough? Now we move forward and now we have all the elements, candidates or proper candidates. Now what we need to do is we need to sort them. And we need to produce them in the sorted manner. So now there are two ways to do this. The first one is you have a vector. Okay, you have a vector. But the next option is to remove duplicates. So now what you can do is you can insert all the element candidates in a vector, then you need to sort them. Then there is a function known as duplicate one, and you can directly use that function to remove the duplicacy, but that would result into a little bit more hazardous. So what you can do is, whenever you think about having elements in sorted order and removing the duplicates, we should think about the data structure known as set. If we just insert all the elements in the set, it would be automatically be in sorted order and all the duplicates would be removed, because set only stores unique elements. So instead of storing all the elements in set, then sorting it and then using STL to remove all the duplicates, this is much simpler than just inserting the elements and then just telling what is the value at the nth. Okay, now there are also two options to this. Also, you can just use the set and you can start a for loop and you can go till the value n. This is also feasible, but cherry to the cake would be, okay, I would explain it to the very last. Okay, so now what is the time complexity to insert elements in the set? To insert elements in the set, time complexity is log n. So if we insert n, so if at max, if we have all the elements as n, L1 into L2, L1 into L2, and inserting them would be multiplied by log n. So that is still feasible. 10 to the power 5 into log n 10 to the power 5 is still feasible and is still less than 10 to the power 8. So that would be also feasible, and iterating over that is also done. Iterating over all the n1 into n to the n1 into n2 candidates would have a time complexity of n1 into n2 only. That is still feasible. So now let's move to the implementation, and that would give you a better idea. Okay, so the first thing we need to have is we need to have a set of data type n, because we would insert all the elements as s and we would name it as s. Now what we would do is we would simply iterate over I is equals to 0, I is less than L1 and I plus plus. This will iterate on all the elements of the array A. Now we would again have a nested loop, int j is equals to 0, j is less than L2 and j positive. Fair enough. Now what we would do is s dot insert a of I added to b of I itself. Fair enough. Now there is also one more thing that needs to be done. It is told that if the number of values is less than the nth value, okay, it is told that if n is greater than the size of the set, then it returns -1. So what we would do is, if s dot size is less than the uppercase n, then we would simply return -1 from this point. Else we would go down and we would have the first iterator where it would point to the very first element, because we can't access the indices of the set itself. Now what we need to do is we need to have int count is equals to 1 and count is less than n itself. Okay, and then we need to count plus plus. Fair enough. Now what we need to do is at each point we need to iterate over it. At the end we would retrieve the element stored in the it itself. Okay, we are getting a correct output for the compilation. Let us just submit this, and yes, we got an AC. Now let us quickly do a dry run for the first sample test case, because second sample test case is a little bit long. So initially we have the set itself, so we would just write here the set. Now what we are doing is int I is equals to 0 and j is equals to 0, I0 j0, 1 plus 3 is equals to 4. Okay, then I0 j1, 1 plus 4 is equals to 5. Then again after this j is complete, so again I would iterate I is equals to 1, I is equals to 1, j is again equals to 0, 2 plus 3 is equals to 5. Then I is equals to 1 and j is also equals to 1, 2 plus 4 is equals to 6. So now after this what would happen is in set it would have the duplicates element, remove the duplicates element in the sorted order, that is why it would have 4, 5 and 6 itself. Then if the size is less than n, we would return -1, but here 3 is within this range. Okay, number of elements in this set is greater than that. So now it would point to the very first element it.begin. Next, what would be the case is we would go from I to n. Okay, why I to n? Because we have already successfully on the first element. So 1 is less than 3, so it would come here itself. Then 2 is less than 3, we would come here. After that, 3 is equals to 3, so it is not less. This part would be false. So at the end, this would be pointing to 6. That is why we are returning the value 6. Now there is one more dimension to this. Instead of using a for loop for this point, we can directly exclude this point, and we can use something known as PBDS, that is policy based data structure. In policy based data structure, we have some hidden, okay, we can call it hidden, but it is not hidden, to be honest. So it is hidden, known as ordered set. Okay, ordered set, we can directly use something known as ordered set, where we can directly access the index of it. Fair enough. That was just a bonus point. I didn't cover it because this question is meant for an easy level question. So that's it for today. Thank you and have a nice day.